Hello dear students, welcome to my channel and welcome to this playlist in which we are discussing about signals and systems. We are discussing about the signals first. We are starting it from the very base. So up until now we have seen what is a signal and what is a system. We have seen few types of signals like initially we have seen what is continuous time signal and discrete time signal. After that we have seen what is analog signals and digital signals. We have seen what is periodic signals and non-periodic signals, and today I'm going to talk about even signals and odd signals. Even signals and odd signals. So let's start with even signals, or it is also called a symmetric signal. I might wonder why is it called a symmetric signal. So giving a basic definition of even signal is a function, let's call it xe of t. So the function xe of t is said to an even function. A function xe of t is said to be an even function of time t if it is symmetrical, if it is symmetrical about the vertical axis. Okay, if my signal is symmetrical about the vertical axis, then that signal is called to be an even signal. Okay, if you want me to teach you it and otherwise, then the inversion of time axis does not change the amplitude of the signal. I don't understand why I'm talking about time axis, because it is symmetrical about the vertical axis, which means what is your horizontal axis or what is your x axis. On x axis you are having time. So inversion of time axis means if you are going from 0 to infinity, so if I invert it, so now you are if first you initially if you were going from 0 to infinity, now you are going 0 to minus infinity. So if my signal, when it was going from 0 to infinity and when it was going 0 to minus infinity, the values of both signals remain same. If the values of both the signals remain same, then it is an even signal. Okay, then it is an even signal. uh, to understand it mathematically, let me tell you what is the condition for a signal to be an even signal. If you remember in previous lectures as well, we always take a condition for a signal to be whatever that signal is, so that we can represent them mathematically. Okay, I've already told you that you will need a little bit of calculus here. So what is the condition for a signal to be an even signal? So simple. If my signal is let's say x of t, then x of minus t must be equal to x of t. Okay, for a continuous time signal, x of t must be equal to x of minus t. Okay, so which means if the value of my signal at t equal to 1, if the value of my signal at t equal to 1 is minus if the value of my signal at t equal to 1 is 0, then the value of my signal at t equal to minus 1 also should be 0. Okay, that's what makes it a symmetrical or an even signal. Similar ways, for a discrete time signal, what do? We take samples, right? Time samples. So at x of n, at n sample, the value of x of minus n must be equal to x of n, which means um, if I'm taking second sample at n equal to 2, is if the value of my x at n equal to 2 is 4. Okay, then the value of my uh, x at n equal to at minus n must be equal to 4. Okay, so both these value must be matched. Now if you remember correctly, what happens when you take a case of cosine wave? Okay, I think you will understand better if I make you understand graphically, if I represent things graphically. So let's go to graphics here. So we're talking about even signal. So cos x or cos phi or cos whatever angle you want to take is an even signal. So see, here I'm having symmetry. See, uh, let's imagine this straight line, this y-axis, as a mirror, and you are looking at that mirror from the sideways. Okay, so on the right side of the mirror and on the left side of the mirror will be equal. See, it is giving you a mirror effect or a symmetrical effect. So let's try to verify what I was telling you about few minutes ago, that if I'm taking, let's say I have a point here. Okay, at this point the value of my signal is here. At the same point, if I take the same point on the at x of t equal to x of minus t, so this was my x of t, the value of it is this, and if I take it at x of minus t, then the value of it would be same. See, the value is remaining same at both instants, value is not changing, which means x of t is equal to x of minus t, and that is why we call a cosine signal, or a cos signal an even signal. Okay, now let's move to the other type of signal, which is odd signal. Okay, the odd signal. So unlike even signal, odd signal is something what is not an even signal, or opposite of even signal. So how do you define the odd signal? So let's say we have a signal xo of t. Okay, xo of t, o for odd, xo of t, and we define it like that: a function xn of t, a function of xo of t is said to be an odd function of time t if it is anti-symmetrical about the vertical axis. Okay, a function xo of t is said to be an odd function of time t if it is anti-symmetrical about the vertical axis. What do you mean by anti-symmetrical? That mirror effect what we were getting in the cosine function. See, we were getting a mirror effect here in the cos function, right? That will not be produced here. Okay, so that means anti-symmetry. So anti-symmetry gives us an odd function, or odd signal, or anti-symmetric signal. Okay, if you want me to define it in another words, then uh, we can say a signal is said to be odd signal if inversion of time axis also inverts the inversion if the inversion of time axis also inverts the amplitude of the signal. Okay, see, the inversion of time axis also inverts the amplitude of signal. See here, what we were having here for cos function, the inversion of time axis, like here the value of this point is 0. So when we inverted the time axis, which means when we went on the negative side, the value remained same, right? But that will not be the case in the antisymmetric or odd signal. Okay, the example of odd signal is a sine wave. So see, this is a sine wave. Okay, so the value here, see, and value here are not same. See, it is actually negative. Okay, it is actually negative, it is not following symmetry, right? Because if you take this y-axis as a side way of mirror, then this is going like this, so it is not following symmetry, it is anti-symmetry. Okay, but what if I had it like this? Then it would have been asymmetric, right? If it was like this, but actually it is not going that way, so it is anti-symmetry. And what I was saying, that value over here at t equal to this instant and t equal to this instant on on the negative side is not same. See, here it is having value in positive, and here it is having value in the negative, which means it is not having same value, which means that the when we inverted the time axis, the amplitude of the signal also got inverted, right? When we took negative t, the amplitude also got negative. See, here we have positive time, positive time and positive amplitude. And when we inverted the time, the amplitude also got inverted here, which was not the case for even signal. Okay, so that is your odd or antisymmetric signal. How do we define that? We have just seen how do we define that, but how do we define it mathematically? So condition for a signal to be an odd signal is x of t is equal to minus x of t. For a continuous time signal, x of t is equals to minus x of t. So if we take an example over here, we are having value of x of t here. So when we take minus x of t, let's take minus x of t. So the same point here we are having negative value, right? So we are having x of minus t, which means x of t is equal to minus x of minus t. Okay, for continuous time signal, and similarly for if you want to go for a discrete time signal, then it will be x of n is equals to minus x of minus n. Because what do we do in discrete time signal? Again, we take samples. Okay, at a regular time interval we take samples, so n is nothing but samples. Okay, now let's come to graphical representation of odd and even signal. I have already shown you about the cos signal and sine signal, graphical representation of cosine signal and sine signal. Okay, so a cos is an even signal or even function, a sine is an odd function or odd signal. And we have already seen about the symmetry and inversion of amplitude with inversion of time, which is not here. See, here we are inverting the time axis. When we inverted time axis, what are we getting here? We are getting same value, which is not the case here. We are in here, see, in the odd signal, when we invert the time, what we are getting here, we are getting negative value of it, right? So the inversion of time is inverting the amplitude, right? And it is in cosine function, cos function, what we are having a symmetry. See, a mirror effect we are getting, but in sine function we are not having symmetry, we are having anti-symmetry. Okay, we are having anti-symmetry. So it is, that is why cosine function is called even function or symmetric function, sine function is called anti-symmetric function or an odd function. Okay, now you might say like, okay, we figured out what is even function, what is odd function. Okay, before we go to that, let me present you with one more example. Can any of you tell me if this signal is an even signal or an odd signal? Okay, if this signal is even signal or odd signal. See, this signal, here let's put a mirror over here. So is it getting the symmetry? Is it getting the same values? Yes, it is getting the same values, right? So this signal is just like cosine signal, which means this signal is an even function. Okay, or even signal. Whereas we see here this signal, see, it is not maintaining the symmetry, which means when we invert the time axis, we are getting inverted value of amplitude as well. See, at this instant of time, the value of my amplitude was something like this. Okay, but when time got inverted, the amplitude also got inverted, which means amplitude became negative. So this function is an odd function. Okay, so now you might ask, sir, okay, we know now what is an even function and what is an odd function, but where and how do we use it? Like why are we learning this type of all the types of function? Okay, what is the significance of this function? So this both of these functions, even and odd, both functions, we use these signals for specific harmony or frequency content. Okay, if you are studying power electronics, then you might be dealing with harmonics, there are so many harmonics. You will be facing second, third, fifth, seventh, ninth, 11th, right? You will be dealing with lot of harmonics. So in order to deal with harmonics and understand them, you will need to understand the odd and even symmetry of a signal. Okay, it is very important to understand odd and even symmetry of the signal. And in order to get rid of that harmonics, harmonics are never good for your systems. So in order to get rid of that harmonics, what do? You design filters, you design you design LC filters, you design RC filters, you design LR filters, right? You design LRC filter. Okay, so all those filters, okay, in that filter design, this odd and even symmetry is used. Okay, in order to get rid of whatever harmonics you are getting or whatever noise you are getting. Um, if you are working in power electronics, or if you are working in power system, this way this will be helpful to you. If you are working in any other signal processing fields, it will be helpful to you as well, because wherever you will go, I think you will find even odd signals and symmetry of that everywhere. And let's come to how do we do it, right? How do we do it? So we can represent every single signal, which can be represented by mathematical equation. Any signal that can be represented by mathematical equation can also be divided into two parts, an even part and an odd part. Okay, we can divide it in even and odd part, and that actual signal will be equal to the addition of that even part and odd part. Okay, we can divide any signal that can be uh, expressed mathematically with uh, with its even and odd part, and the aggregate of even and odd part will be always equal to the value of that function only. Okay, so uh, let's come to that. So let's take a function. Let's take function x of t. Okay, and we can represent this signal with its even and odd parts. So this x e of t is the even part, and x o of t is the odd part of that signal. Okay, x e of t is an even part of that signal, and x o of t is an odd part of that signal. Okay, and now let's call it equation 1 for a moment. Okay, let's call it equation 1. Now in order to understand this, let's substitute minus t for t. Okay, so instead of t, let's put minus t. So when we put minus t instead of t, what will happen? This t will become minus t. So x of minus t is equal to x e of minus t plus x o of minus t. Okay, we just substituted t with minus t. Okay, now think from the basics what we have just seen. Okay, from the condition which required to be a signal, condition which signal required to be an odd signal and even signal. What was the condition? Let's see it again. Okay, let's see for a even signal first. It was x of t is equals to x of minus t. Okay, if if signal is even, which means I can write x of t is equals to x of minus t. So can't I write this x of minus t equal to x of t only? So that's what we did from the definition only. Here, instead of this minus t, we wrote this t. Okay, and for odd signal, what was the definition of odd signal? It was x of t is equals to minus x of minus t. Okay, x of t is equals to minus x of minus t, but we are already having x of minus t here. See, we are not having minus x of minus t. What we are having? Only x of minus t. So what can we do? We simply put this minus outside of this bracket and put it over here. So that's what we do. We put this minus over here and we kept t as the way it was earlier. Okay, now let's call this equation 2. And now let's perform the addition of equation 1 and equation 2. Okay, we are simply adding the equation 1 with equation 2. Okay, so now let's watch it for the left hand side. What will happen on the left hand side? Xt plus x of minus t. Okay, xt plus x of minus t will be equal to xt plus x of minus t will be equal to what we have on the right hand side. Let's see on the right hand side first. Here now let's see on the right hand side, x e of t plus x o of t. Now we are simply doing addition, so what will happen? It will be plus x e of t, and then what sign we are having here? See, we are having minus sign, we are having negative sign over here, so we will be having minus xo of t. So this xo of t was positive, this xo of t is negative, so this positive and negative will be cut out with each other, and we will be left with x e of t plus x e of t. That makes two of them, so we will be left with 2x e of t. So see here, we are having first left hand side x of t, which came from here. Then we had, what do we had? X of minus t, which came from here. And then what we had? X e of t plus x e of t, which means 2x e of t, right? So this equation we are getting. Now we want to find the value of the even part of that signal. Okay, even part of the signal. So let's make x e of t a subject. Let's make x e of t a subject. So what will happen? This 2 which is multiplied with x e of t will go in denominator, right? So x e of t will be equal to 1 by 2. Okay, x e of t will be equal to 1 by 2 x of t plus x of minus t. Okay, will be equal to x of t plus x of minus t. Now I want you all to know this one thing, that x of t plus x of minus t will never be equal to 0. X of t plus x of minus t will not be equal to 0, because you don't know if that signal is an even signal or odd signal. The whole aggregate of this odd and even part. Okay, so this x of t and x of minus t are different. See here, if I want to find the x of t of this point, let me see if I can annotate it using something. Okay, so sorry, I cannot find anything to annotate, but let me use the mouse cursor itself. That value of x of t, what we are having, value of x of t here, it is this. Okay, the value of x of t is this, but the value of x of minus t will be this. Okay, so in the case of even signal, they are equal. Okay, x of t and x of minus t, they are equal, but in the case of odd signal, we are having this value, but x of minus t we are having negative value. Okay, so it is different for both odd signal and even signal. That's what I wanted you to know, that for x e of t, it will be equal to 1/2 x of t plus x of minus t. Okay, for even signal it will be like that, but for odd signal, if I put this plus over here, if I keep this plus over here, this plus, so can you tell me what will happen if I keep this plus as it is for odd signal? The x of t plus x of minus t will be 0, right? Because the values are contradictory. They are opposing each other. See, x of t and x of minus t. See, they will cancel each other out for odd signal. For even signal, it will be doubled, right? So now we want to find the value of odd signal. Let's find out what how do we get it? So for odd signal, what we will do is simply subtract the equation 1 from equation 2. So again, because we are subtracting this plus, apologies, this plus will become this minus, right? So this plus will become minus, and on the right hand side, because we are taking xe of t plus xo of t minus xe of minus t minus xo of minus t. So what will happen in this case? The the even signals will be cut out, right? How, you ask? Because x e of minus t will be equal to x of x e of t, right? So and there were two negatives, so the x e of t will be cut out with the other x e of t, okay, and we will be left with this xo of t, which is positive, and then we are putting one negative value here, so minus minus will be plus, and we will be left with 2 xo of t. So we'll be left with 2 xo of t. And now we want to make subject xo of t as subject. So what we'll do, we will send this 2 into the denominator, and we will be left with xo of t is equals to 1 half x e of t minus x of minus t. Okay, so let's again quickly go back to graphical representation and verify this one. Okay, so when we take this one, okay, we are taking odd function, so the value of x of t here will be this much. Let's call it 5. Okay, and x of minus t will be this much, which means it will be minus 5. Okay, so it will be minus 5. So what does this says? Is equals to x of t minus x of minus t. Okay, so the value will be, x of t's value was 5, right? Minus x of minus t's value was minus 5. So what will happen here? Minus minus will be plus, and 5 plus 5 will be 10, divided by 2 will be 5, right? What we will be getting will be 5, right? So it is opposite in the way of even signal. Okay, so this equation, the first equation, the equation of x e of t, which you are seeing in yellow, is the even part of x of t, and the other equation for x o of t, the other equation which you are seeing in yellow, is the odd part of the x of t. Okay, and this whole calculation we did, it was for continuous time signal only. Okay, if you want to go for discrete time signal or real time signal, it will be same as well. Okay, the calculation will remain same. What will change? Instead of x of t, we will have x of n. Instead of x e of t, we will have x e of n, and instead of x o of t, we will have x o of n. Okay, so now if I want to write the equation of even part and odd part for discrete time signal, how do I write that equation? So it will be like x e of n, instead of this t we will be putting n, so x e of n is equals to 1 by 2 x of n, instead of t we will be having n, plus x of minus t. So instead of x of minus t we will be having x of minus n. Okay, so simply basically you will be replacing t by n. Whenever you see t, you will be replacing it by n. Same will happen with the odd part. Instead of xo of t, we will be having xo of n. Instead of firstly xo of n equal to 1 half x of n minus x of minus n. Okay, so we are again simply replacing this t with n. Okay, so I hope you understand that that was not any big deal to understand, so that's why I didn't mention it in the presentation as well, because it was pretty self-explanatory. You can understand it by yourself. Okay, And one more important thing, because I think you may not if you are may not have understood about that, don't worry, because we have not seen the addition and subtraction of the signals yet. So when we will be dealing with addition and subtraction of the signals, at that time you will get that cleared. Okay, we'll be doing it in near future. Okay. Now if we are when we are already speaking about addition and subtraction of signals, specifically for this even odd segment, what will happen when we add even function or even signal with an odd function or an odd signal? Okay, when we add even function or even signal with odd function or odd signal, we will be getting even function, or sorry, we will be getting odd function or odd signal. It is just like numbers. Okay, it is just like numbers. When you add an even number with odd number, what you will get? You will get odd number, right? Let's for instance say I want to add an even number, let's say 4. We are having 4 and we adding it with any odd number. I am adding it with 3. What I will get? I will get 7. What is 7? 7 is an odd number, and this is true for any even and odd numbers. Okay, when you add an even number with odd number, you will get an odd number. So same thing will happen with signals as well, signal or function, whatever you want to call them. Same thing will happen with them as well. Whenever you add an even function with odd function, you will be getting an odd function. Okay, so now can you tell me what will happen if I add two odd functions? Just like numbers, when we add two odd numbers, let's say I want to add uh, 3 with 9. Okay, both 3 and 9 are odd numbers, right? So when I add 3 with 9, what I will be getting? I will be getting 12. What is 12? 12 is an even number. So the same thing will happen with odd functions as well. When I add an odd function with another odd function, I will be getting an even function. Okay, now I will left this one for you guys. What will happen when I add an even function within another even function? Just like numbers here as well, I am adding an even function. Let's say I'm adding 6 with 4. When we add both 6 and 4 are even numbers, right? So I'm adding 6 with 4. I'm adding even number with even number. What I will be getting? I will be getting 10. What is 10? Even number, right? So I want answers from you guys. What will happen when I add an even function with another even function? Okay. Um, I would want you to mention the answer of this in the comment sections. Fill it out below in the comment section. Okay. The first one who will mention the answer will get shout out from me in the next lecture. And that was pretty much it from my side about even and odd signals right now. Till now, in the future we will be watching the numericals related to the same, but in the meantime, for now, we are keeping the discussion till here. In the next lecture we will be seeing what is energy and power signal and random and deterministic signals. And I hope you all are understanding whatever we are going through, and I want you all to revise it. And if you have any doubts related to this lecture or any other lectures we have seen this far in signals and systems, please mention it in the comment box. I will try to answer as many of them as possible. So let's keep this lecture till here, and I'll be meeting you in the next lecture. Thank you very much for listening, and goodbye everyone.